It was inevitable. Here we go. Word problems with trigonometry. You know what's going to happen, and here it is. It's no big deal. Come on, let's not complain about it. More ladder questions, though. A 6-meter long ladder leans up against a building. If the ladder makes an angle of 60 degrees with the ground, how far up the wall does the ladder reach? Most of you stop and think, oh my god, this is so hard. You know why you think it's so hard? Because you're not imagining it, or you're not taking the effort to draw a diagram. Once you draw the diagram, it'll all show up and it'll all click into place. Trust me, trust me, trust me. Okay, so first off, we know our good friend Sohcahtoa. Always remember them. They're going to help you out all over the place. Anyways, you have a 6-meter long ladder leading up against a building. So here's our building right there, let's say. And a 6-meter long ladder is leaning up against it. So the building, 6 meters, that's the ladder. And there's the ground. And so the ladder makes an angle of 60 degrees with the ground. There's the ladder, there's the ground. Ladder, ground, 60 degrees is what the angle that it makes up. How far up the wall does the ladder reach? So here, or how far up the building does the ladder reach? So there's the building, how far up? We want to know what this distance from there to there, how far up does it reach? Well, what do you see? There's the ladder. There's that, and there's how far it reaches. I see a right angle triangle. Look at that. Where we know that length, we're trying to find this length, and we have that degree right there. This calls for Sohcahtoa. To that angle, this side, the unknown side, is opposite, and this side here, because the boxy thing is pointing to it, is hypotenuse. We have a hypotenuse and opposite. O and H, that's sine. So we're going to use sine theta is opposite over hypotenuse. Our theta, our degree, is 60. Our opposite, we don't know, so call it op. And our what just happened there? Our hypotenuse is 6 meters, but just who cares? Just 6. What is that line? Okay, whatever. So we want to figure what opposite is. We got to solve for opposite. It's being bugged by the 6, which is dividing it. Opposite dividing it is multiplying. So we times this side by 6, times this side by 6 as well. And the 6's cancel out. You're left with opposite. And then 6 times the sine of 60. I would do the 60 sine first. 60 sine gives me that 0.866666. Multiply it by 6 times 6 gives me 5. That's going to be 5.20 is what that gives me. So opposite side is 5.20, and that makes sense. So this length here is 5.20. That's how far up the building the ladder reaches. 5.20 meters, because it's all meters. See, it's just drawing a diagram. I know it's messy, sorry. Finding the right angle triangle, and then doing your thing. Sohcahtoaing it. It's not that hard. Really. A 25-foot tall flagpole casts a 42-foot shadow. What is the angle that the sun hits the flagpole? So, we need to draw a flagpole, the sun, and a shadow. So, how do we do this? Well, first off, let's draw that. Here's the sun back here. Do it, do it, do it, do it, do it, do it, do it. Looks like a spider. So I'll put a happy face on it. Your spiders are never happy. Yeah. And anyways, so there's the sun, and it casts, and here's the flagpole. With the flag right there. Or the other way, whatever. There's the flagpole, and then this flagpole casts a shadow. And first off, they say that the flagpole is 25 feet, Americans, 25 feet tall, this flagpole. And the shadow that it casts onto the ground here is 42 feet long. Whoops. I was going to say feet. 42 feet long. That's the shadow there. That's how long the shadow is. Then they're asking, what is the angle that the sun hits the flagpole? So we want to figure out at what angle does the sun hit the flagpole? Well, there to there completes our right angle triangle for our story, and we want to figure out at what angle the sun hits the flagpole. So we want to figure, oh, first off, there's our right angle triangle, 90 degrees. The sun is hitting the flagpole, that's right here. So how high up the sun and the flagpole do they, right here. This is the angle we're trying to find. Right there. That's our unknown theta. Well, from that angle, what are these two things? That is adjacent, and that is opposite. Opposite and adjacent. According to Sohcahtoa, opposite adjacent is tan. So I'm going to go tan theta is equal to opposite over adjacent. We don't know the theta, so let's just leave it as that. Opposite is 42, adjacent 25. 42 divided by 25 is 42 divided by 25. Come on, calc. 42 divided by 25 is 1.68. Inverse tan that to get rid of the tan. So we inverse tan this side. Do the same to the other side. Inverse tan cancels out, left with theta. 1.68 inverse tan gives us inverse tan gives us 59.24 degrees. 59.24 degrees is that right there. No problem. Okay, now, just to make things a little more difficult, here's two words here. Angles of inclination and angles of depression. An angle of inclination, or sometimes called an angle of elevation, is an angle going up from the horizontal. So we have a horizontal here, angle is going up, so that's the angle right there. Angle of depression is an angle going down from the horizontal. So there's a horizontal line, and it's dropping below, so that right there would be the angle of depression. So those two things will come into play with a question like this. A kite with a string that is 15 meters long is stuck in a tree. So let's draw a tree. Okay. There's your tree, and a kite is stuck in the tree. And kites look like this, right? Like that. Yeah. There's the kite. K for kite. T for tree. Don't say that you didn't know which was which. It's the thoroughly labeled diagram. That's a K. Anyways, the kite has a 15-meter long string, and it's down to the ground with some kid holding on to it. 15 meters long. it says the string forms an angle of elevation with the ground of 20 degrees. So there's the ground and the angle of elevation. So there's the horizontal, the ground, angle of elevation going up. This angle here is 20 degrees. Based on this, and because the kite is stuck up in the top of the tree, we can figure out how tall the tree is. That's pretty cool, isn't it? You can figure out how tall a tree is based on all this information. Now you have to assume that the kite is right at the top of the tree, and it's 15 meters. I know my diagram isn't very good, but 50 meters from the top of the tree, diagonal from the string down to where the person would be. Yeah, and you're probably thinking that doesn't make any sense, but just and there's some leaps of logic here, but let's just go with it, please. Okay. So, there's our angle, 20 degrees. 20 degrees. And there's our distance there, 15. We want to know that distance from there, the top of the tree down. So there, cinches shows us the right angle triangle right there. We want to figure out this distance from there to there. Green tree distance. Well, how do we do that? We have this. What do we know about this angle? Well, that unknown side is opposite, and this side here is adjacent. Who's opposite adjacent? Sohcahtoa. Opposite adjacent, that's tan. Alright, so, whoops. Tan theta equals opposite over adjacent. The degree we're talking about is 20, so we're going to go tan 20. Opposite, we don't know, so op. Adjacent, 15. Don't need the meters. But we just should know that it is meters. Opposite is being divided by 15. How do we get rid of 15? Multiply 15, because that's the opposite thing to do. 15 times there, 15 times there. So tan 20 times 15. I hope this is not getting cut off on the side, although I'm worried that it is. Let's clear all that away. So the 15s cancel out. We're left with just opposite. And then tan 20 times 15. So first let's do tan 20, or 20 tan, times 15, gives us 5.49, 5.46 is what we should round it to. 5.46. 5.46 is what we get. Okay. I'm worried that you can't see this properly, so I'm just going to move this over here. That's what I wrote, if you couldn't see it. Anyways, and so 5.46 is the answer. That's the height of the tree. 5.46 meters. I guess so. Okay, so there you go. Doesn't seem to be very tall of a tree, but this is a odd scenario, but it is. That distance is 5.46. Done. Okay, last one. Elise is standing at the top of a 50-foot building and sees her friend Molly. If Molly is 30 feet away from the base of the building, what is the angle of depression from Elise to Molly? By the way, Elise's eye height is 4.5 feet. Now this question's a little better. But the question up here, you got a kid holding a string, but we have to sort of account for that height there, right? The kid's not on the ground, or it's not like an ant holding onto the string. This is kind of more realistic, this question here. So, Elise and Molly. So Elise is on the top of a building. And there she is. Okay, anyways, body's a little broken. That's alright. Um, especially that, yeah. Okay, anyways. So there's Elise at the top of a 50-foot building. The building 50 feet. Elise's eye height is 4.5 feet. So that means from there to there, eye, right there, is 4.5 feet higher than the building. So from there to there is 4.5. Molly's on the ground. Molly is 30 feet away from the building. So there's the building, 30 feet right about, I'll just see right about there. So there's Molly. And she's also got some broken body parts, it seems like. I don't know why, but okay, there's E for Elise, M for Molly. What we're asking is, what is the angle of depression from Elise to Molly? So from Elise's eye to Molly's, I guess, her feet. I know, technically, another little, it should be, should specify part of her body, but it should be from eye to eye, actually, but whatever. So from Elise's eye, because her eyes are 4.5 feet above the ground, like the question said, to Molly. What is the angle of depression? Now this is tricky. Tricky, tricky, tricky. Here's Elise's eyes, right there. There's the horizontal. There's her eye. There's the horizontal. Going that way. We want to figure out this angle here. How do we do that? Oh, by the way, remember, this is 30 feet right here. Where's our right angle triangle? It's a little sloppy, but 50 going up, 4.5 there. So in total, 54.5. Building plus Elise's body up to her eye is 54.5. So that right there, oops, let's do it yellow. That yellow, yellow, yellow building is 54.5 meters. This is 30 meters. Right angle triangle. There's the sight line from Elise to Molly. We want to figure out this angle here. How do we do that? That angle is part of this other triangle that's way over here somewhere. It's not really asking about anything in here. It's not asking about that. Because an angle of depression, remember, is an angle that there's a horizontal and it goes below the line. So it's this right here. Well, if you remember your grade 8 geometry, you'll know of something called the Zed Rule. And in the Zed Rule, I'll do it in pink. Here's a Z. This angle here is the same as this angle right there. Trippy? Yeah. This angle and that angle are the same. So yeah, we can't find this angle with all these numbers, but we can find this angle because it's inside this right angle triangle. And because those two are the same, we're in the money. So that's our unknown angle we have to look for. I know you're probably like making weird scrunchy-eyed faces at me right now or at the computer screen. Just trust me. And if you forgot this Z rule, F rule, C rule, all that stuff, then maybe just ask me again or watch the video on angles and parallel lines. You have two parallel lines, and when it makes a Z, the little things in the armpit of the Z are equal. So because of that, we can figure out this missing angle with that information there. So our triangle that we're looking for is right here, the yellow one. Yeah, it's now red because whatever. I'm just really ruining this, aren't I? That triangle there, and we have this length at 54.5. Let's get that 50 out of the way. It's confusing us now. 54.5, 30, that missing angle. Let's identify the sides of this triangle. This is adjacent. That's opposite. And that's what we need. That's a tan. By now, you know opposite adjacent, it's tan. Tan theta is equal to opposite over adjacent. Let's go back to my black. We don't know theta, so we'll just leave it as tan theta. The opposite is 54.5. The adjacent is 30. 54.5 divided by 30. Trust me, well, I'll just do it in the calculator anyways. 54.5 divided by 30 is 1.82. 1.82, and we're going to inverse tan this to get rid of the tan. Same the other side. That gives us nothing. It cancels out. Theta is the inverse tan of 1.82. The inverse tan of 1.82. 1.82 inverse tangent gives us 61.21 degrees. 61.21 degrees. That is this. 61.21 degrees. That is the angle of depression here. Sorry, that's not the angle of depression. That's just that angle there. Because like I said, the Zed rule, that is equal to that. So that is also then 61.21 degrees. See? Think out of the box a little bit, and you can figure it out. Yeah, it was tricky, but come on. It's not. It's doable. Here's 2 skill testing questions. Enjoy them. Bye-bye.